This is 5.2, solving systems of linear equations by substitution. Before, we solved systems of linear equations by graphing. Today, we're not looking at graphs to figure out where they intersect. We are substituting one into the other. So, we use substitution to obtain an equation in one variable. So we want our equation to be only x's or only y's. Then we can figure out what 1 is. Then we solve that equation and substitute the answer into one of the originals to find the other variable. So find x, then plug it back in, and you can get y. So substitute to get one variable, solve it. Plug it into an original, and you get the other variable. Solve this by substitution. Y equals 3x minus 2, and 5x minus 6y equals 8. This first one is already solved for y, so I'm going to plug it in to the second for y. So I take what y equals and plug it in instead of y. This tells me what is y, so instead of writing y, I write all of the stuff that y is. So this would be 5x minus 6, and instead of y, I write what y equals, 3x minus 2 equals 8. So I am substituting equation 1 into equation 2. I distribute the 6, and 5x minus 18x plus 12 equals 8. Now I'm going to solve for x. To do that, I can combine like terms. So I have 13x plus 12 equals 8. Subtract 12 on each side to get my x term by itself. And 13x equals negative 4. My x term is by itself, but it's not just x. So I need to undo this multiplication. So I'm going to divide. So I have x equals 4 over 13. I know what x is now, so I'm going to plug it back in to one of my original equations to get y. Since this one is y equals, that's going to be a little easier to solve for y. So I'm going to plug it into equation 1, and instead of x, I write the value that I found for x. So y equals 3x minus 2, that is y times 3 times 4 over 13 minus 2. 3 times 4 is 12, 1 times 13 is 13. So now I have y equals 12 over 13 minus 2 over 1. When you have a whole number, remember it's always a fraction where the denominator is 1. To subtract fractions, I have to have common denominators. So to turn 2 over 1 into a common denominator of 13, multiply top and bottom by 13, and you get 26 over 13. So y equals 12 over 13 minus 26 over 13. 12 minus 26 is negative 14, all over 13. So now I take my x value and my y value and put them together in one point. So my answer, my solution of where these two original equations intersect is at the point 4/13, negative 14/13. Let's try another one. In the equations, 4x plus 2y equals 0, and y equals 1/2 x minus 5, I'm going to take what y equals and plug it into y in the other one. So this is going to have 4x plus 2, and instead of writing y, I write what y equals. So I have 1/2 x minus 5 in parentheses. Then distribute this 2. 4x comes down. 2 times 1/2 is 1, so that's just x. and 2 times negative 5 is negative 10. Solving for x now, I have 5x minus 10 equals 0. To get x by itself, I am going to add 10 to each side, then divide by 5, and x equals 2. Then I take this x equals 2 and plug it into an original equation to get y. So I choose the one that will automatically give me y, and I have y equals 1/2, and instead of x, I know x is 2, so 1/2 times 2 minus 5, that's y equals 1 minus 5, y equals negative 4. So my solution, my answer, is the point 2, negative 4. I have one more example. So if I am given these two equations, 3x plus 4y equals 8, and 3x equals 2y plus 2. So I have to substitute one of them into the other. Since I have a 3x equals, I know what 3x is. 3x is 2y plus 2. So instead of this 3x in the first equation, I'm going to replace that with what it equals, because that will give me only y's, so I can find y and then x. So instead of 3x, I write what 3x equals, which is 2y plus 2, and then plus 4y equals 8. I can combine like terms to get 6y plus 2 equals 8. Solving for y, because that's my only variable right now, subtract 2 on each side, and 6y equals 6. Divide each side by 6, and y equals 1. Now I take this y and plug it back into one of these two to get what x equals. You could choose either one to plug it into. I'm going to choose equation 2 because it's closer to having x by itself. So 3x equals 2y plus 2. I know what y is, so I plug that in here for y. So 3x equals 2 times 1 plus 2. Simplifying this, 3x equals 2 plus 2. 3x equals 4. And x equals 4/3. So my solution, my answer to where these two equations intersect is at the point 4/3, 1.